Here is another example of a multi-body force problem. As a reminder of the steps for force problems, you must read the problem, draw your free body diagram, set up Newton's second law, solve for the unknown, and once you get an answer, reread the problem and check your solution. In this example, we place one box on top of another, with the bottom box being pulled along a level surface. As a force problem, make sure to highlight masses, clues on acceleration, and forces, including the direction of forces. Especially highlight what is being asked for. You must draw a free body diagram for each object. Start by drawing in the forces that would be present without the other object. Now add the forces acting between the objects and apply Newton's third law to correctly set up the directions in action-reaction pairs. Set up a sensible coordinate system for each object. Declare Newton's second law for each coordinate of each object. Because this example involves friction, we will need expressions for the normal forces first, and hence we start in the y direction. Notice you can combine the equations through substitution to eliminate one of the unknowns. Now that we have the normal forces, we can write out our expressions for the frictional forces. Remember to match each frictional force with its corresponding normal force. We are now ready to set up Newton's second law in the x direction. Note that the acceleration of the objects are the same and are non-zero. We can combine the two equations which eliminates all the internal forces of the system, effectively treating it as a single object with only the outside forces to the system acting on it. Solve for the unknown Then plug in with units before reaching for your calculator. Use your answer to go back to the previous part of the problem and substitute in to solve for variables involving the internal forces. Finally, reread the entire problem and make sure you have answered all questions in a sensible way. As always, check against your free body diagrams in detail.